Hello everyone, welcome to Homeschool, and we are with the second session on a chapter, the language of chemistry, which is the first concept of class 9 ICSE syllabus. And I'll be covering the entire syllabus of all class 8, 9 and 10. Every concept of the chapter has been explained in a very detailed way, and on if you want an information about all the concepts, please go to the description box where you will find the links on all the concepts. And don't forget to subscribe our channel to learn chemistry in a better way and in an easier way. Okay, so in our last session we spoke about an element, symbol of an element, importance of the symbol. Later we spoke about a compound, how a compound can be formed and how it can be represented with the help of a chemical formula. And today we are with the most important topic called the valency. It's a very essential thing to learn about valency because many concepts of chemistry are dependent on this particular concept, valency. Okay, so let us talk about the valency in detail. So what do you mean by a valency? It has two important definitions. We are learning the first definition now. Two important definition, guys, remember. The first definition, the number of hydrogen atoms that can combine with one atom of an element is called valency. Okay, try to understand the definition here. The number of hydrogen atoms that can combine with one atom of an element is called valency. See, to understand in a better way, just try to write like this. Element, we have a particular element. Let us imagine the compound with hydrogen, and later let us figure out the valency of a particular element. Okay, let me select the element called chlorine here. Can you be able to think of any compound of chlorine with hydrogen? Can you be able to guess any compound of chlorine which should have hydrogen in it? So what is the common compound? HCl. Yes, we keep telling about this compound, hydrochloric acid, HCl. We keep using it in a normal chemical labs to show a simple reactions, isn't it? So HCl. See, this Cl can combine with only one hydrogen atom, yes or no? So the valency of Cl is just 1. Okay, this guy called Cl can combine with only one hydrogen, so HCl is formed. It cannot combine with 2 atoms of hydrogen, it cannot combine with 3 atoms of hydrogen. It can only combine with 1 atom of hydrogen, so the valency of Cl is 1. Let me take another element, oxygen. Okay, so can you be able to figure out a compound of oxygen which also has hydrogen? Yes, very simple compound. Every day we keep using this, that is water. Oxygen has combined with how many hydrogen atoms, guys? It is combined with 2, isn't it? So the valency is 2 here. Let me take another element, nitrogen. So can you be able to imagine a compound of nitrogen with hydrogen? Definitely, the compound is ammonia. You see here, this nitrogen has combined with how many hydrogen atoms? 3. So the valency of nitrogen is 3. This is what we call valency. Okay, see, valency of chlorine is 1. Why? Because this chlorine can combine with only one atom of hydrogen. Valency of oxygen is 2 because oxygen can combine with 2 atoms of hydrogen. Valency of nitrogen is 3 because nitrogen can combine with 3 atoms of hydrogen. So based on the combining capacity of an element with hydrogen atoms, we defined valency this way. Okay, but this cannot be applied for all the elements. Only for a few elements like Cl, oxygen and nitrogen, we can able to guess their valencies based on this concept. See, why? Because many of the elements do not combine with hydrogen only. If you take zinc or if you take gold, platinum, copper and all, they won't combine with hydrogen that easily to form the compounds. So in that case, you cannot able to guess the valencies of all the elements present in our nature, isn't it? So this is a very limited definition, does not have much importance. Okay, so now I am going for the second definition here. It's a very important definition. This is what the definition we always use it in chemistry most frequently. The number of electrons lost, usually metals will lose electrons, and the number of electrons gained, non-metals always gain electrons during a chemical reaction. So that number we will call it as valency. Okay, so to understand this definition, you must first understand some basic things about a periodic table here. Okay, so periodic table, it has got 18 vertical columns. Okay, these vertical columns we will call it as a group. This is group number 1, this is group number 2, group number 3 to group number 12 will come in this region, group 13, group 14, 15, 16, 17 and 18. Okay, say vertical columns, and try to understand group number 1 to group number 12. All these elements normally we call them as metals. Normally we call them as metals. Okay, during a chemical reaction, they will always lose electrons. Say, chemical reaction is nothing but a business between the electrons. In a normal language, business in the sense what? Giving and taking money. Some people give money and some people will take money. That's what we call business. But in case of chemistry, say a chemical reaction means what? Some elements give electrons and there are some other elements who take those electrons. So this giving and taking electron business only, we call it as chemical reaction. So here some elements give electrons, I said. So which elements give electrons? Metals will give electrons. Who are called as metals? The elements which come in group 1, elements which come in group 2 and elements which come in 3 to 12. All these elements are called as metals. And the elements that come in 13 to 18 groups, they are called as non-metals. These guys are called non-metals. Non-metals. And what do non-metals do during a chemical reaction? They will always take electrons. From whom they will take electrons? From metals they will take electrons. Okay. So what you have to remember is group number 1 elements. Can you able to tell the elements of group number 1? The first element is actually hydrogen. Okay, next is lithium, sodium, potassium, rubidium, cesium. Okay, so these elements come in group 1, and in group 2 what elements will come? Beryllium, magnesium, calcium, strontium and barium. Okay, group 13 elements, boron, aluminium, and at least 2 elements you can remember, isn't it? So carbon, silicon, here nitrogen, phosphorus, here in the 16th group, oxygen, sulfur, fluorine, chlorine, helium, neon, argon. Rest of the elements may be not necessary for your level. Just at least try to remember the first 2 elements in every group. Okay, so all these elements and the elements that come from 3 to 12, all these guys are metals. What do? They always lose electrons. Okay, and here what I am going to give you is Group wise valency I will give you. Actually, I am giving you a shortcut to remember the valency of the elements. Okay, actually you should know the valency of every element that is present in a periodic table, where it is not possible for us to remember the valencies of all elements, isn't it? Okay, so here this can work as a shortcut for you to remember. See, all these elements, group 1 elements, that is lithium, sodium, potassium, these elements are quite famous actually. You have to remember them. Okay, so all these elements will show the valency plus 1. All these elements will show the valency plus 1, guys. Okay, so what is the meaning of plus here? You should know the meaning. Plus means the element is losing electrons. The element is losing electrons during chemical reaction. Okay, so here all these elements during chemical reaction, they will lose 1 electron. That is why we say all these elements have a valency plus 1. Okay, so similarly, elements that will come in group 2, that is beryllium, magnesium, calcium, strontium and barium. Okay, all these guys valency is plus 2. Okay, plus in the sense what I said, they will always lose electron. They come in a category of metals, isn't it? So metals always loses electrons during chemical reaction. So how many electrons these guys are losing? 2 electrons they are losing. That is the reason plus 2 is the valency here. Okay, and elements from group 3 to group 12, they don't have a fixed valency. They have a variable valency. About variable valency we will discuss little later. Okay, and coming to the group 13 elements, they have a valency plus 3. Okay, so these guys also will lose electrons during chemical reaction. That is why indicated with the sign plus. And how many electrons they will lose? 3 electrons they will lose. Okay, and coming to the 14th group elements, you know they have a valency plus 4. They will lose 4 electrons during the chemical reaction. And coming to the 15th group elements, they have a valency minus 3. You see, I have written minus 3. So what is the meaning of minus here? Minus means the element gains electrons. This is a shortcut of writing an electron. Okay, instead of writing a long word electron, I can use this symbol also here. So the element gains electrons during a chemical reaction. Okay, then that is indicated with the sign minus here. So 15th group elements, that means our nitrogen and phosphorus, these guys always gain electron. They don't lose. They will always gain electrons from others. How many electrons they gain? They gain 3 electrons. That is why they have a valency minus 3. Okay, and coming to the 16th group elements, you know their valency is minus 2. That means they will always gain 2 electrons from others. And coming to 17th group elements, their valency is minus 1. They will always gain 1 electron from others. 18th group elements will have 0 valency. Okay, because they don't lose electrons and they don't even gain the electrons. It's because they are much more happier with the electrons they have. Okay, so they are in a stable condition. Stable condition in the sense being in a state of happiness. Very much happy, it's because they have enough electrons with them. They are just like our hand. Okay, see, our hand is happier when it has all the 5 fingers, right? So like our hand, they have 5 fingers, they are happy with whatever electrons they have. But these guys, coming to the first group elements, it's like they have an extra finger. Okay, imagine if you have an extra finger, how difficult we feel and how inconvenient it is. Yes, the hand cannot do the things that he has to do properly. So When this hand will be more happier when it is having an extra finger when you remove it, isn't it? It's like you are removing an extra finger. Plus one means what? These guys have one extra finger. When they will become happy? When you remove that finger. Yes or no? So group 2 elements is like they are having 2 extra fingers. So when does these guys become happy? When you remove those 2 extra fingers. Okay, plus 2 means what? It's like having 2 extra fingers. Plus 1 means having 1 extra finger. You know, 13th group elements. Plus 3 means what? These guys have 3 extra fingers. How inconvenient it is. So if you remove the 3 fingers, they will become more happy. Okay, say plus 4 in the sense having 4 extra fingers. Okay, and coming to these guys, minus 3 in the sense, you know, among the 5 they have only 2, they don't have 3 fingers. Minus means what? Losing, you know, they don't have 3 fingers. So when do they become happy? When these guys take 3 fingers, like yes or no? When you add them 3 fingers, they'll become more happier. Okay, fine. And minus 2 means what? You know, they don't have 2 fingers. Minus 1 in the sense they don't have 1 finger. So when they will become more happier? When they take 1 finger, when 1 extra finger is added to them, they become happier. So being in a state of happiness means what? Having 5 fingers, no? So these guys is like they have an extra finger, so they are not happy. So one finger has to be lost. That means 1 electron has to be lost. Okay, so these guys is like having 2 extra fingers. These guys are like having 3 extra fingers, 4 extra fingers, and here 3 fingers are not there. Among a 5, 3 fingers are not there. So when you add those 3 fingers, they'll become more happier. Okay, so this is the easiest way to remember the valencies, I feel. So try to remember group 1 valency, 2 group 13, 14, 15, 16, 17 and 18 valencies. They are very important. And now coming to the concept of radicals. Okay, so what do you mean by a radical? Radical is nothing but an atom or group of atoms with positive or negative charge. Positive or negative charge is called radical. Okay, say for example, if I just write a symbol Na, it means what? Sodium, 1 atom of sodium. Okay, so atom is always neutral. It is because the number of positive charges, that is protons, is always equal to the number of negative charges, that is electrons. Okay, but you know, the same sodium, if I write like this along with the valency, when I write sodium, okay, then it becomes a radical. Very simple, guys. When the same symbol is written along with a valency, okay, then it becomes a radical. Okay, so during a chemical reaction, the elements will get converted into radical, and these radicals will combine with another radicals to form a chemical compounds. Okay, so this is all about a radical. Radicals can have a positive charge or negative charge. Say for example, Cl is there. Okay, and during a chemical reaction, you know, this Cl will become Cl minus. You know, we represent Cl along with the valency. That means what? Cl has gained 1 electron. Why it has gained 1 electron? Because it is not having 1 finger. Okay, so Cl has only, imagine Cl is like our hand. It's not having 1 finger. So to become happy, it should gain 1 finger. It should, you know, take 1 finger. Yes or no? 1 finger has to be added. So that's why it will gain 1 electron. So Cl minus, Cl along with the charge when you write, then that is called radical. Just Cl is not called as a radical. It is just an atom. But Cl along with this charge is called radical. Okay, like that, radical is nothing but it is an atom with a charge or group of atoms also. Okay, group of atoms in the sense, in our nature we have, you know, CO3 minus 2. CO3 is one group. That group has a charge, and such groups are called polyatomic groups. What do we call them as? Polyatomic groups. Many atoms combined together, they form as a group, and the group has a charge, either positive charge or negative charge. Okay, so those groups are called polyatomic groups. And now I am giving you a chart which elements has what valency and what do we call them as. Okay, and I am giving the list of some polyatomic groups and their valencies as well as their names. Okay, say the very first and important group, CO3. Okay, let me write it like this. Its name, carbonate group. Carbonate group, we write it as CO3 minus 2. So minus 2 is the valency. Okay, so the charge itself we call it as valency. Yes or no? It may be a positive charge or negative charge. You know, minus 2 is its valency. And in a similar way, sulfate group, you know, it has a symbol SO4 minus 2. Minus 2 is its valency. Okay, so similarly, sulfite SO3 minus 2 is its valency. Okay, and you can observe here SO4 is called as sulfate, SO3 is called as sulfite. Okay, so usually you know, both of them has sulfur atoms and both of them have oxygen atoms. So the one which is having more number of oxygen atoms is called with the name ATE. The name should end with ATE. The one which is having lesser number of oxygen atoms, you know, their names should end with ITE. Okay, so knowing the names is also very important. Same type of groups, if the oxygen numbers are different, you know, the one which is having more number of oxygen atoms, name should end with ATE. The one which is having less number of oxygen atoms, you know, their names should end with ITE. Okay, so here sulfate means SO4, sulfite means SO3. Both of them have the valency minus 2 only. Okay, fine. So actually these are some important polyatomic groups which are showing minus 2 valency. Okay, so these guys are showing what valency? Minus 2 valency. They are showing minus 2 valency. And coming to the polyatomic groups which will show minus 1 valency. HCO3. Okay, HCO3. Okay, its name bicarbonate. Bicarbonate. Okay, what is its symbol? HCO3 minus 1 we say. HCO3 minus 1. Okay, so bicarbonate radical we will call. Anything which is having a charge, anything which is represented with the charge is called radical, no? So in other words, bicarbonate radical also we can say. You know, it's having a valency minus 1. And hydroxide radical, that means OH. You know, it is also having a charge minus 1. Okay, and nitrate NO3 minus 1. Nitrite, you know, NO2 minus 1. Okay, you can connect here. You see, both the groups have nitrogen and oxygen, but this group has maximum number of oxygen, no? So the name has ended with ATE. And this one has less number of oxygen, no? So the name has ended with ITE. Okay, so any groups which are similar, which are made up of similar atoms, you know, then while giving the name you have to be very careful. You have to check the number. See, this is one atom of nitrogen, one atom of nitrogen. Okay, the differentiation is there in case of oxygen atoms, right? So you have to consider the one which is having maximum oxygen atoms as ATE, the one which has minimum oxygen atoms as ITE. Okay, so these two groups, this is called nitrate group, this is called nitrite group. You know, all these guys have minus 1 valency. Minus 1 valency. Polyatomic groups having minus 1 valency. Okay, and now coming to phosphate group. Okay, phosphate group, its symbol is PO4 minus 3. It's having a valency minus 3. Similarly, how do you write phosphite group? How do you write phosphite polyatomic group? Phosphite in the sense PO3 minus 3. Okay, so these groups have minus 3 valency. They have minus 3 valency. Okay, phosphate is this one, phosphite is this one. You know what is their charge? Minus 3 is the charge. Okay, and now coming to, say for example, valency of Cl valency is how much? Minus 1, isn't it? So join them and write, you will write it as Cl minus 1, right? And this Cl minus 1 can be called with the name chloride, okay? Remember, when an element is having a negative valency, then the element's name should end with IDE. Okay, ide should come at the end. Actually, you cannot call it as chlorine radical. You have to call it as chloride radical. Okay, got to know? So similarly, nitrogen is there. So what is the valency of nitrogen? Previously, I gave you group-wise valencies. Nitrogen valency is minus 3, guys. So along with the valency, if you want to write N minus 3, you will write no. So this N minus 3 is called as nitride. It is not nitrogen, it is called as nitride. Okay. So similarly, phosphorus is there. Phosphorus belongs to 15th group element. What is its valency? Valency is minus 3. Join with the valency. If you put the valency with the symbol and write, then you will be writing like this, no? P minus 3. P minus 3 is called as phosphide. Okay. So this IDE we have added everywhere. Okay. When you will add IDE and at the end, only when the element, single atom is having a negative valency. Valency can be 1, 2, 3 or anything. If the valency is a negative valency, it's having a negative sign, then you will add in the name IDE at the end. Okay. And similarly, oxygen is there. 16th group element it is. What is its valency? Minus 2. So how do you write? O minus 2 you will write. These are your radicals. Okay. And what is the name of this radical? Oxide. You don't call it as oxygen radical. You will call it as oxide. Okay. So similarly, Cl is there. Okay. Cl is already over. Fine. Sulfur is there. Its valency is also minus 2. And when you write it as a radical, S minus 2 you will write. What is its name? Sulfide you will write. Sulfide you will write. Okay. Clear everybody? So, but only when the valency is negative, then only that IDE will come at the end in the name. Otherwise, if the valency is a positive, no IDE, nothing. Just name of the element only you will mention. Say for example, sodium is there. Its valency is plus 1. Okay. When you write it as a radical, you will write it as Na plus 1. Okay. You don't call it as sodide and all. IDE will not come here. It is just written as sodium. That's it. Sodium. Name of the element only is written. Okay. Say Mg is there. Mg is having a valency plus 2. Okay. So when you write it as a radical, you will call it as Mg plus 2. Okay. What is its name? Magnesium only. Magnesium radical we say. Or magnesium ion we will say. No IDE and all at the end. Clear everybody? So this is one important point that you have to remember. Whenever an element has negative valency, if you have to call the radical with a particular name, at the end we add that IDE. Okay. If they are having positive valency, we don't call them with any IDE at the end. There are no tails here. Just call them with the element's name only. Okay. So this is about valency. And now let us discuss about variable valency. If you can observe, I gave you valencies of group 1, group 2, then 13th to 18th I gave. But I did not give valencies of group 3 to group 12 elements. Isn't it? It is because they have variable valency. Each element can have 2 or more than 2 different types of valency. Okay, that is called variable valency. Variable valency in the sense each element or atom having two or two or more than two valencies is called variable valency. Okay, say for example iron is there. Okay, iron will come in that group number 3 to group number 12 category. Okay, that middle of the periodic table, and iron has two valencies here. Iron has +2 valency and iron has +3 valency also. Depending on the conditions during chemical reaction, iron can lose two electrons or iron can lose 3 electrons. Okay, +2 means what? 2 extra fingers, so 2 electrons has to be lost. Okay, +3 in the sense what? 3 extra fingers, so 3 electrons have to be lost. 3 fingers have to be lost. Okay, so +2 valency, +3 valency. Two different valencies can be shown by a single atom or element. That is called variable valency. Okay, say whenever iron is having +2, we will write it as Fe +2. So Fe +2 is called with the name ferrous. Okay, actually the name of iron is ferrum. You know, iron, I is not the symbol here. Latin name for iron is ferrum. So Fe, first two letters we have taken for the symbol. Okay, so when it is having a +2 valency, we will call the iron with the name ferrous. It is ferrous ion. Okay, and when it is having +3, we write iron as Fe +3, and it can be called with the name ferric. Okay, remember which is the lowest number? 2 is the lowest number. So this is called lower valency. Actually this is lowest valency, and this is higher valency, highest number if it is there, higher valency. Okay, so if you represent Fe with lower valency, then it is OUS, we should add at the end, it becomes ferrous. And if you represent an element with the highest valency, you know, IC you should add at the end, so iron becomes ferric. So this is about iron valency. So similarly copper is there. Okay, copper also has variable valency. It can show +1 also and it can show +2 also. So can you able to give its name? Cu, if it is having +1 valency, what is the name you will give? Cu, if it is having, you know, +2 valency, what is the name you will call for this? Just apply here what I told. Lower valency, if you observe, OUS you should add at the end. Higher valency, if you observe, IC you should add at the end. No? Similarly, apply the concept here. Copper, right? Copper. So lower valency means what you should add? OUS you should add at the end. So it will become cuprous. Okay, and this will become cupric. Okay, higher valency, higher number means higher valency. IC you should add at the end. So the names also you should be familiar. Whenever I say cupric, that means copper is having a valency +2. Whenever I say cuprous, that means the copper is having a valency +1. Whenever I say ferric, iron, which valency it has? +3. Whenever we say ferrous, iron only, which valency it has? +1. So with respect to the names, from the names also you can able to tell what valency is observed in a particular atom, like in case of atoms having variable valency. Okay, so this is all about valency. You have to remember the valencies of groups and elements that I gave you, along with the special names we have learned. With this knowledge, in my next video, I will teach you how to write chemical formula for the compounds. Okay, so till then, keep revising the concept and don't forget to check the description box for all the concepts that come under a chapter. There we have posted the links on all the concepts of the chapter. And don't forget to subscribe our channel for more updates to learn the chemistry in an easier way. So if you like our video, please like, share, and also comment. Thank you so much.